Here we have two gears. We've got one gear which we're going to turn, which we're going to call the driver, and one gear that is going to be turned, which we'd call the driven gear. So when we're going to turn this, before we look at any numbers, I want you to just have a look at the two dots marking the positions of these gears and see if what we can infer from the speed of which they will rotate. So we're going to turn our driving gear by 1 revolution, and we see that our driven gear here has moved further in the same time, which tells us this gear has been turning faster. That is something we'll immediately see if we keep rotating them. Now, because these are spur gears, by spur gears we mean that they have teeth that interlock, then we shouldn't get any slipping. You'll notice that our driver gear is turning one way, here it's turning anti-clockwise, and our driven gear is turning clockwise, so the direction that these rotate in alternates, it changes every time we get a set of teeth interlocking. Okay? Now this gives us the fact that our small gear is turning faster than our large gear, gives us something that we would call the velocity ratio. Now the velocity ratio is rather simple. It is how fast our output gear is rotating compared to how fast the input gear is rotating. Now we can get our velocity ratio by looking at the number of teeth on the input gear divided by the number of teeth on the output gear. The number of teeth on this large gear we've used for our input here is 18. So 18 teeth. The number of teeth on this small gear is 15, which gives us a ratio of 6/5 or 1.2. That tells us that our output gear is rotating 1.2 times faster. So our velocity ratio here is greater than 1. And having a look at this, if we ever get a large cog pairing to a smaller cog, then we will always get the small cog turning faster, making more rotations in the same time. Now we're going to swap these over and see what effect that has. Now we swap these two cogs over, so now our driving gear, our driver gear, is the small one. So now you can see for 1 revolution of our driver gear, we can see that our driven gear does not make a full revolution. That means that its rotational speed is less. It has been decreased. Okay? Now, what is our velocity ratio going to be here? Our velocity ratio, or the VR, is going to be, well, it's the number of teeth on our input, which is 15, divided by the number of teeth on our output cog, which is 18, which we find is 0.833. Now, what does this tell us? It tells us that our output gear is moving about 1/6 less fast than our input gear. So this is an example of a reduction gear, where it would increase our force but reduce our speed, and this one where we had the large cog linked to the small cog, is an example of a multiplier. It increases speed but reduces the force that we get out. Now, you would probably be familiar with this type of gear if you've ever ridden a bicycle. You tend to have a larger gear at the front of your the front where your pedals are, linked to a smaller gear at the back. This means that your your legs don't have to go round at the same rate as the wheel, which means that it would be a force multiplier but a speed reducer. Okay.